Hi there, Andrew Jackson, AJ Design Studio. Got something quite different today. There's no CAD in sight, no SolidWorks, no Rhino, just sketching. So I've been meaning to put something together for a while on model planning and how you might approach modeling different forms and what to look for and how to analyze a form and break it down and come up with a strategy to start your model. I find I need a strategy. Sometimes I can just do it in my head, but I always find it helps to have a quick sketch, just to explore a few different ways potentially to model something. And it also helps to be able to look at a form and be able to analyze how it's constructed, whether it's truncated forms, interpenetrating forms, or more fluid forms. So I'm just going to sketch over some of these images I have grabbed off the net. There's a mixture of forms here, sort of primitives through to more fluid forms. So yeah, I'll start over this side here and just do a quick sketch over, just sort of analyze things. So this form here, analyze things first. The first things that appear to me are the fact that there's two axes of revolution. So you've got two forms. So those are your two axes of revolution. And then there's two forms. There's this one here. And then this one here. Okay, and then the next thing that happens to those is they're truncated. So there's a plane that runs through and chops this piece off here, and the same like on the ground plane here. So there's a plane that runs through there, creates that line there. So that's very simple. A couple of revolved forms that are then truncated to create the final form. Okay, moving over here, this looks like a similar sort of thing. So again, that looks like it's got a revolution, axis of revolution through here, and then again, simple revolve form that is then again cut. Okay, so no need to overcomplicate things, like you've got to break it down into its base shapes. Like so, and then the base, that looks like you could probably revolve that. So again, axis of revolution, bit of form to the sides, done. Okay, and to make the arm here, that's probably a sweep. Okay, nice and simple. Okay, well, third one here, which is again interpenetrating forms, primitives. So we have a cylinder. So you could do an extrude, like so, cut a hole through the middle, and then you end up with the resultant line around here, where the two parts intersect, where the second cylinder comes in and intersects. So again, this looks like a revolve, and then some fun on the strain relief down here. Okay, something a bit more interesting from a modeling point of view anyway, this camera. So starting off, there's cylindrical form here, cylindrical form, and then there's the main form of the camera, which looks like you could extrude this section here and then work over the top. This is like a lozenge form and it has some shape to it, so you'd have to build maybe this piece here as an extrude, and then if you wanted to make this curvature continuous on the end here, you probably have to make it a fill surface or trim it back to make it a four-sided surface, like that. So 4 boundaries, and then you build that surface there, and same on this end here, And then to create this area here, that looks like it's an extrude. So I'd say just an extruded cut. So if you imagine this as a surface that's getting extruded through here and cut to give you the area around the controls. Okay, and this part line here, or this join, that's just merely resultant of the intersection between the camera body and the lens. Okay, something more involved. Let's have a look. Guitars. You've got Stratocaster versus a Les Paul standard. So Stratocaster, straight away, things that I identify is that the main area of the body, like around here, is pretty much all planar. Okay, and then this area here drops off. So to model this, I would start by creating that main form. Like so, then extruding it to give us a solid, and then identifying what sort of, where this area here, you want to drive a cut through there, which rolls off, as you can see. So that's going to cut this piece out, but that's the relief for your arm. Okay, and then the final thing is to identify what this blend is, which is pretty much standard right the way around because I know how this is made. It's routed, so then you'd go in and create a nice fillet or blend right around the outside, including down here, so it goes down and around. Okay, so that's the steps. You'd extrude it, which is the first thing. Second thing is you figure out the next largest feature on the body, and then third is the fillet around the outside. So that's something you've got to identify as I break things down in my head into primary, secondary, sort of tertiary steps. So when you see your object, go, okay, what does that look like without smaller details on it? What does it look like without that? What does it look like without the fillets? Okay, so if we come over here to the Les Paul standard, and pretty much the Les Paul, most of the body, like the back part behind the binding, is an extrude, whereas the top part is like a carved top. So this has form, comes up and over like so, and up and over that way. There's several ways you could do this. First one that comes to mind is you could, if we ignore the cutout, which is here, so you just imagine the guitar's just one piece like this, you can create a racetrack in the middle, and then you can create sections around there, like so, and then you build all these surfaces around the outside, if that makes sense. I don't actually like the idea of that, because then you have issues with continuity through here onto this little flat thing down the middle. I know you've got pickups and stuff through there, but a better way to do it would be to again ignore the cutout area over here, and then you draw the center line profile, and then pick a few areas like here and here, and another profile through here, and then you build that as your primary surface through here. And then to make the ends, we need to make that out of four-sided surfaces. So what we'll do is we'd go in and trim these areas. So if I erase that, Okay, so now we could build a four-side surface in here, as you can see. 1, 2, 3, 4. 1, 2, 3, 4. And we also use the center line, and that fills out those ends there. Okay, and then the last thing you do is you just drive a cut through here to create your cutout. Okay, covered that one, I think. Let's have a look at this one here. I picked this because this has a disappearing edge. So this form here has a planar circular face. So that's something I'd set up straight away. I draw a side elevation control where you capture the main lines, which I think look like, but that's what the central section would look like. Okay, and then you probably create a front control as well. In the front elevation, you'd capture okay, and then you've got to decide how to build this crease up the side here. And this crease almost looks like it runs forwards. So how to approach that? And that's kind of a tricky area because you could build, this is a planar face here. You could, say if your crease ran out there, you could build, this is one surface or two surfaces and mirror them across here. So there's another one to get that curve face, but then this area here is kind of tricky. So if that's our crease there, and the crease stops, so you'd want to have the surface, another surface here, so we'll change colour. So we've got this patch here, we've got this hole we need to fill, which has 1, 2, 3, 4, 5 boundaries on it. So I'd probably run another control sketch through here, a section, and then you'd build one surface there, which has got 1, 2, 3, 4 boundaries on it, and then this one here, 1, 2, 3, 4 boundaries on it. Okay, but this line here, that is where the crease ends, and this surface up here spans over both this surface and this surface, so there's no crease on this surface. That one next, all these at the same time, and then you go in here and build this stuff. Okay, up here it's like a lozenge form, so I've done some lozenge forms recently with SolidWorks. So if you're going to make a curved continuous end, I've been building a surface, so okay, so if you imagine that's your lozenge, slightly exaggerated. To build these ends here, I've been trimming them back and trimming the surface back here like that, and then building a four-sided surface, 1, 2, 3, 4, and then use that center line as well. So that means you can have a G2 connection there and there. Otherwise, if you don't want to do that, you just revolve this end section here, but then you end up along here on that join line, you end up with a very obvious G1 connection. Okay, so this form here, I think you'd build the center here, then you build your ends, and then for the recess, this dimple, that curve there, you'll project that on, that be resultant, obviously, where it intersects with the with the green surface. And then to create the actual dimple, you've got several options there. You could arguably, you could go like this, so you create a center line, then you create some sections going in the other direction, and then you build your first surface there, and then you do what I did on the ends here with the green. You basically trim that area out and then make four-sided surface in the ends there. So in plan view that would look like circle, center line, that's your first surface, and then your second is you trim that out and build your second surface in there, which seems like a lot of work, especially if that dimple's very shallow. This kind of setup's better when you've got a much deeper section, and also if it's, say, the dimple's on a, you know, much more in section, much more sort of complicated area. Okay, other way to do it, which I've done recently with quite a bit of success, is basically you say that's the surface before it's trimmed. You can put a point down a certain distance, so whatever that is, X, and then you make a fill surface of using SolidWorks, pick the outside, and then as a constraint curve you pick that point, and then you end up with a nice equal dome going through there. Let's have a look at this chair first. So this chair, first thing I think when I see chairs like this is the best way to do it is to build an overbuilt surface, because getting surfaces to match together and nice blends can be quite problematic. So this was an overbuilt surface. You'd figure out maybe the center line, and because of its overbuilt surface you need to make it four-sided, and then you have another boundary, you have another boundary, and then you have another boundary, and then you end up invariably with several cross curves to control the form, and then you mirror that over, or you build it all full width like so, which means you don't end up with any curvature issues along the center line. Okay, and when you overbuild something, the second step would be to go, okay, you make your main form, and then the second step is to create the trims to cut all of this out. So you end up just with your chair. So you end up with the inside. But the thing with this chair is I can kind of tell, if you did that, what if you wanted to have a different curvature along this edge, along here, to what's going on along here. So what I think another way of doing this would probably to create, so if you've got a center line, and then maybe you create an overbuilt shell but it only goes up to here, like so. So that's your first surface, and then you can build these little nublet wings here. The arms is a second exercise, and you trim this back and put these blends in here on the arms, and that means you can have different forms to these two areas, so you can deviate. The reason they've got this cut here is for seat performance, so this can go forward and back, and the arm can move independently, So if this was joined here, there's a bit of an issue with chairs. When you lean back here, the arms want to go inwards. So that's why they've got this cut. Yeah, or there's another way you could do it again, which is fully independent, which would be you create your center line, and you create your back, and then you create the seat, and they have a theoretical edge where they meet, and then you trim those areas back, and then you create a blend through there, and then you figure out the sides. So in this case it's kind of hard because there's quite a big blend here, so I'm not quite sure. You probably have to have the surface going out and then build upwards like that, and then you'd have to go in and do your blend through here, so you end up with two big blends. Yeah, lots of options. Okay, last thing, this chair down here. So this chair down here is kind of different again, because this is the main center part of it is overbuilt. So if I figure out down, let's just figure out what we can see here. I can see a big highlight going around the outside. I can sort of see quite a defined interior surface. Okay. And I can also see very defined, these legs are like cut through. So you've got these interpenetrating forms here with the legs, and you've kind of got this fluid form at the top with a big radius around the outside. So again, I think this has probably been built as an overbuilt surface. So we built one half, we'll probably come down here, come up, and that down like that. Okay, and then we go through and trim it with this blue line here. So we just end up with this interior piece here. And then we've got this whole exterior edge, which runs all the way around, runs around this way. Okay, so that gets built. And then lastly, the legs, the legs cut through that form. So if you zoom in here, it's very obvious that the legs pass right through that. So a nice green edge here. The legs run right straight through there. So, I mean, you could try and build this with a series of patches, but in my experience, if you can build a form like this as an overbuilt surface and trim it back, you're in a much better position, because to build this out of patches, you'd be building the back, and then you've got to chop that back and blend it into a small piece of seat, and then go up the side here, and you're going to have continuity, or you'll be tweaking quite extensively to try and get this area to work, to try and get these boundaries working. Yep. Right, so that's me. I'm going to wrap this up. This is my first model planning. So lots of stuff. You know, you can become second nature at doing this kind of stuff, especially like looking at this kind of patch layout on objects that aren't, you know, primitives or truncated forms. But yeah, anyway, hope you find this useful, and I hope to do more of this. Thanks for watching. Andrew Jackson, AJ Design Studio. Bye.